All right, we're going to look at converting into scientific notation, in and out of scientific notation. So if you need to, you can write this down. If you know what you're doing, you don't have to. It's just a review. My first question to you is, if I have a number like this, is that in scientific notation, 103? No. What if a number like this? If I have 107 times 10 to the 4th, is that in scientific notation? No, that's still incorrect. The general rule is this. We're going to have, in scientific notation, it's going to be times 10 to some power up here, but what goes here is important. Who can help me with that? What are we going to put there? What's true about the number that goes there? Between 1 and, actually, close, between 1 and 9.9. We can even go up to that. So 9.9 will go here. So that's the general rule. When you start off, and some exponent can go in this spot right here. So if I have the number of 103, and I want to put it in scientific notation, when it stands as 103, and I want to put it to the 10th power, like to the times 10 power, it's times 10 to the what? Anyone know? I think someone said it. To the 0. That 10 to the 0 is like saying 1. So 103 times 1 is 103. But at least I'm starting to get it in the tens, in the times 10. So what I'm going to do is take the number, and I will say, okay, I've got my 103 times 10 to the 0. It's assumed the decimal is there. I need to get it in that range that we have over here. So I need to move the decimal point 2 places to make a smaller number. I'm going from 103 to 1.03. So what I'm doing is I'm taking a 10 out of the number, and I'm taking another power of 10 out of the number. Well, I have to put them somewhere. I can't just take them and not account for them. So what happens is that 10 to the 0, when I took a 10 away, now it's 10 to the 1. When I took the second one, I have to put it somewhere. I gave it to this. Now I have it to the second. 103 times 10 to the second. Whenever I see the exponent is a positive number, I know that that number is 1.0 or greater. Okay? So when I see a number like 528, when you put it in scientific notation, I know your exponent is going to be a positive one. Positive exponents get you numbers greater than 1 or greater. So if we look at the opposite, what if I have a number like, 0.0067? And I want it in scientific notation. I can start like this. I can say, okay, 10 to the 0. Now, I need to take this number and move that decimal so that my new number is what? What's my new number going to be? Yep. Good, 6.7. So it's 1, 2, 3 places to get it to 6.7. But what you should realize is this. Am I dividing or multiplying by 10 each time I do this? You're actually multiplying. If I have my 0.0067 and I multiply it by 10, I now have 0.067. And if I multiply it by 10 again, I now have 0.67. And if I multiply it by 10 again, I have 6.7. So you're actually multiplying, because what's happening to the number? It went and got bigger. When it gets bigger, from 0.0067 to 6.7, the number gets bigger. When it gets bigger, you must be multiplying. So you're multiplying by a series of tens. Where do those tens come from? This right here. Well, it's got nothing to give. Who cares? You're going to take it anyway. So you moved it once, it's a -1. Twice, it's a -2. The third time, it's a -3. So it's 6.7 times 10 to the -3. And because it's a negative, I know the actual value is less than 1. And it is. This number, 6.7 times 10 to the -3, is equal to 0.0067. They are the same exact value. Okay? It's just a different way of writing it. So, it depends if it's positive or negative and where you're going. Next thing. Are we okay with that? Nodding, I'm happy. Alright. So the next thing. After we do that, here's another example. We then have multiplication and addition. I'll give you a little thing to help you. If you have exponents like this, if I have 2.0 times 10 to the 4th, and I'm going to multiply it by 2.0 times 10 to the 5th, when you multiply numbers together, what's going to happen is the exponent number, I'm sorry, it's this thing here, the 5, gets added together. So I'm going to end up with a number around 10 to the 9th. It may end up eventually going to 10 to the 10th or 10 to the 8th, but it's around 10 to the 9th. So if I have an answer that's not even close, then I did something wrong. Because in multiplication, you add your exponents together. So you get 10 to the 9th. 2 times 2 is 4. I'm done. That number actually fits in between 1.0 and 9.9. So I'm done. If I have this one, if I have, that's not good. Excuse that. If I have this number, that's recorded, that's ridiculous. Say I have 3.0 times 10 to the 3rd times 6.0 times 10 to the 2nd. What do I get with that? I would right off the bat say, hey, it's multiplication, exponents get added. If it were division, exponents get subtracted. But it's multiplication, exponents get added, so I'm going to be around 10 to the 5th. Now I do the multiplication of the numbers up front. I have 3.0 times 6.0. That gets me 18. 18 times 10 to the 5th. It's not written correctly, but that's what you get. Now you have to convert it into scientific notation. Because we said it has to fall between 1.0 and 9.9. I have to take the decimal and move it one place. So I'm taking a 10 away from it. Where does the 10 go? Right there. 1.8 times 10 to the 6th. Okay? And that's close to what I would have thought of 10 to the 5th. That's close enough. But if you end up with something like 1.8 times 10 to the, I don't know, negative to the 1st, well, you subtracted. You did it wrong. Right? Division is a subtraction of exponents. But addition and subtraction is a pain. That's why it's easier to do it on the calculator instead. Addition and subtraction, you have to get them to the same, like you do with fractions. Did we talk about that before? Getting to the same, fractions, you have to get to the same denominator. Well, you have to take numbers like this. If I have 3.1 times 10 to the 3rd, and I want to subtract from it 2.0 times 10 to the 1st, to do this out, you have to have the same exponent. Just like a fraction would have when you have 1/2 plus 2/4. You can't just add that together. You have to convert this into 4. No, you can't. Stop. Then you would get 4 over 4. And if you notice, the denominator stayed the same. You have to convert this. I'll tell you the way I do it. Not that you have to really do this because you're going to use the calculator. I convert the higher one into the lower one. I don't feel like going. Any clue why this is happening? Because my computer's performance is slow. That's nice. Alright, that's not good. Who cares? I'll take this one, this one right here, and I will convert it over into 10 to the 1st. What does 3.1 times 10 to the 3rd look like when I want it to be times 10 to the 1st? What number would that get me? If I pulled 2 10s from here and threw it there.
3,100?
Close, 310.
Oh, okay.
I'm going to take 2 away from here, not 3. 2 away, 1, 2, 310. Minus 2.0 times 10 to the 1st. My answer will be in 10 to the 1st. because that does not change, and we just said that. This stays the same, just like it does in fractions. And then it's 310 minus 2. What do you get? 310 minus 2 is?
380.
Thank you. Is that written in the correct scientific form? No. So we have to take it and make it right. Who's going to make it right for me? Amy, what do you think? I can't have 308. That's just against the rules. Yep, 3.08 times 10 to the third. Nice job. Okay, from 308 to 3.8, you took 2 sets of 10 away, and you have to account for them. 10 to the first becomes now the third, and that is correct. But it's a lot easier with the calculator. So, we have some problems.